Hi there and welcome to the screencast for Workshop 6. So today we're going to continue looking at the dplyr package, and in particular we're going to look at summarizing rows and how to do all of the operations we've seen so far on subgroups of the data. So instead of on all the data set at once, we're going to do the same commands on subsets of the data within each subset. And this gives us a very powerful way of performing analyses. And we'll also look at the idea of small multiple plots towards the end. So we're going to start by reading in the raw data like we had before, and I'm going to convert it to the clean data set. You'll remember from last time, the clean data set here is where we've altered the level variable with a mutate command to convert it just to the number of the year level. You remember before it was year space 1, year space 2, and so on, which didn't sort nicely. So we want to have it so it will sort nicely. So we're going to start with the summarize command. And so the summarize command essentially takes all of the rows in your data and produces a summary statistic from all those rows. So it reduces your data set down to normally a single row. So if we have run this first command, you'll see that I'm summarizing and I'm creating a new variable called rows, which is equal to n. Now n is a helper function that just returns the number of rows. So here we have 103,666 rows. The second one is then doing two summaries. So I'm computing a total column, which will be the sum of the number of students. So that will be the total number of students across all schools in New Zealand in 2021. And then we're going to compute another one, which is the average, which takes the total and divides by n. So this would be the average number of students in each row. Okay, so on average, each row has around 8 students in it. Now notice that when I do so, the total that I've used to compute the average is what we've already computed beforehand. So when you do summaries, you can reuse the summary that you've already done, that you've computed earlier if you need to. So you can sort of compute things with a multi-step process if you wish. So let's have a look at some examples. So find the largest, which is the maximum number of students in any row. So to find the maximum number of students in any row, I can see two ways to approach this. One, I could just order the data, couldn't I? Because I'm trying to find the biggest, if I just order the data descending, then I can see that the largest number of students in any row is 785. Okay, so this is one way to find the biggest, sort descending. Okay, but perhaps the way that's intended might be to use summarize, and we could instead just say the max is going to be the maximum of the students. Now, the name I've used here is up to me, right? So I could use Charlie instead of Max, for example, and that wouldn't be a problem. Okay, so you can call the name of your new column whatever you like. Okay, so maximum students, for example, would be fine. Maximum students, maybe. Okay. What about the median? Well, we can't use sorting to find the median. Well, I guess we could, but we'd have to sort and then find the one halfway through, which might be a bit tricky. But of course, we can do that with a summarize. So we just say the median is just going to be the median number of students. Okay, so the median number of students per row is 3. So the median function here is used to compute the median, just like the max function here was used to compute the max. What is the lowest and highest year levels in the data? Well, again, we could do this by sorting. Right, so we could just arrange by year level. So we can see that it starts at 1, and then we could arrange by year level descending, and we can see that it starts at 15. So the year levels are 1 through 15. Okay. The other way, of course, is to use summarize. So we could just go for the minimum of level and the maximum of level. Now notice that I've decided not to name these. So I didn't go, A equals. And so when you do that, it names them after the function you're using. So the minimum level was 1 and the maximum level was 15. So typically if you want to reuse these summaries later on for something, then you'll probably want to actually label them so that they are a bit easier to then reference later, right? You don't have to figure out how do I put a bracket in a name when brackets, parentheses in a name when parentheses usually mean a function. Okay. And now we can do something slightly trickier, which is to find the number of Māori students in year 9. Okay, so this is a somewhat more useful thing to be able to do than just the total number of students or the range of the year level or whatever. So how would we approach this? Well, we only want Māori students in year 9. So we want to only pull out the rows with Māori students in year 9. So that's going to be a filter. So we're going to start by doing a filter where we want the ethnic group to be Māori. And the year level to be 9. Now notice here, when I've used the level, I haven't put any quotes around the 9. Because it's a number and level is numeric. So this is a numeric comparison. I would put the numbers, I have put quotes around Māori because Māori is a label, not a number. Or not, and it's not something that that R knows about. So Māori isn't listed up in our environment, for example. So that does the sorting. So now we only have rows where the year level is 9 and the ethnic group is Māori. See, we have 893 of them. And now we can then count the number of students. So we need to add up these numbers because, of course, there's not just one student in each row. In this row here, there's 57, for example. So now we're going to summarize. And we could say number equals sum of students. So there's 17,391 Māori students in year 9. Okay. Obviously, we could break it down by gender as well if we wanted to, by specifying, gender as male or gender as female and so on. Okay, but if we wanted to compute them both, so say we wanted the number of Māori students of each gender in year level 9, then if we're doing filter and then summarize, we'd have to do it twice, right? We'd first filter out the ethnic group Māori, level 9, gender male, summarize the number of students to find the number of males, and then we'd filter out ethnic group Māori, level 9, gender female, and then summarize the number of students to find the number of females. Okay. The group by function allows us to do it both at once. Okay. So essentially the group by implicitly does sort of a filtering for each of the subgroups in turn and then applies the functions to them. So here's an example. Normally when you, so before when we did the summarize and computed the total number of students, that was across all schools in New Zealand and all genders and all ethnic groups and all year levels. Now we're first grouping by school and then doing the summary. And so what this will do is it will perform the summary command within each school. So it's like taking one of the schools out, the first school out, and computing the summary on that first. So for example, doing a filter, the school is, whatever that first school is A1 something or other. I can't remember, let's have a look. A1 Student Limited, so it would filter out just the A1 Student Limited school, and then it would do the summarize on that, and then it would filter out the next one, and so on and so forth, and then bind all those rows back together. So let's have a look and see what the output looks like. So you can see here we just have a single row for each of those groups, and we have the total number of students. Okay. So that's kind of a handy thing to do. We could also do that by any other criteria, right? So how many students are there of each ethnicity? We're going to take our data, we're going to group it by the ethnicity, so ethnic group, and then we'll do our summarize. Okay, so you can see here that we've got this odd group that we had last time as well, international fee paying. That's hardly an ethnic group, is it? Of which there's about 5,500 students. But you can see that the highest is European, followed by Māori, Asian, and then Pacific and other. Okay. How many students are there of each gender? Again, it would be the same, right? So instead of grouping by ethnic group, we would group by gender. Okay, so we can see that there's just about 20,000, or no, 16,000, 15,000, 17,000. Do the maths. 17,000 more males than females in schools. Just going to reopen that so that we get rid of that weird blank area down the bottom. And I hadn't saved it, had I? Oh, no, I'm in the wrong directory, that's why. I was certain that I'd saved it. That's better. Okay. Which school has the most female students in Year 13? So how could we answer this? So clearly, we only want female students in Year 13. So we could use a filter for that. And then once we've filtered out female students in Year 13, or once we've retained only female students in Year 13, we could then compute the total number of students in each school. So we'd group by school and then go from there. So the first thing I would do is do a filter to just drop down to the female students. So gender equals female. Right, so that's female students. Okay, then we'd filter again. We could do it all in one filter, of course, if we wanted to, but we can do it separately as well. We want level is 13, Year 13. Right, so that will be female students in Year 13. And then we would group by school, because of course we've still got multiple rows per school. We'll have 5 rows per school, I think, or possibly 6 rows per school, or fewer, of course, because we've got the ethnic groups, right? So we haven't specified ethnic groups, so we've still got multiple rows per school. So we're going to group by school and then summarize the number of students. There we go. So there's the number of female students in each school, and then of course we could just arrange by descending total, and we find that it is the Correspondence College, Te Ahu o Te Kura Punamu. Okay, so add up number of Year 13 female students per school. Okay, so often answering these questions is just a multi-step process, and the key to answer them is to think carefully about which rows you want to leave in your data set and which summaries you need to compute and over which groups. So let's have a look at another one. Produce a graph of the total number of students by year level. And we've got a wee hint there. It says first get the data frame you want and then worry about the charting. So let's get a data frame. So we need the total number of students by year level. So this is similar to the total number of students by ethnic group or the total number of students by school. It's the same thing, right? We just use a different grouping variable. So we're just going to group by year level and then compute the total number of students. Okay. So you can see it peaks at year 7 and then drops off again. And of course, year 14 and year 15 are somewhat special. So most students go to year 13 only. I think year 14 and 15 may be some additional repeats of that same content. I'm not completely sure. So once we've got the data set that we want, so we could either call this something like we could call this students by year, right? And then we could plot that. So we'd use a column chart for that because we already have the accounts. So our X would be our level and our Y would be our count, which is our total. So there we go. And we might add a total, add a title. So X is going to be year level. Y would be number of students. And the title would be something like that, right? And you can mess around with the colors or whatever. So super interesting in that there's more students at year level 7 than any other level. And that's clearly not the case, right? In practice, like, you know, everyone that's in year 6 this year presumably will be in year 7 next year. And similarly, those that are in year 7 this year are going to be in year 8 next year. So why is there this sudden increase and a sudden decrease again? So this is usually, so year 7 is usually where you go to an intermediate school. And I believe what happens is that students get recategorized at that point. So it's not that, so some students don't actually go directly from year 5 to year 6 to year 7. It's just a different category. So that's where sort of things are normalized at that point. So all students progress to year 7, but what counts as being year 7 is a bit different. So this is sort of an artifact of the way that things are lined up. Okay, what about the next one? Alter your graph from 4 so as to include gender as well. So what we want is we want this same chart, but we want the number of students by each gender and each year level. So to do that, we need to group by 2 things. So we're just going to take the same code that we used before. We'll just copy and paste that to save some time. Oh, we've got this weird thing happening again. There we go. And then instead of just grouping by level, we're going to group by level and gender. And when we run that and have a look at that data set, we can see that we've got the same summary, but now it's split at each year level into male and female. Okay. So this is really where the power comes, right, from dplyr. Generally, even if you're using something like Excel or some spreadsheet program, breaking things down and summarizing over multiple variables at once is a complicated thing to do. So I think you would do this with a pivot table or something like that. And anyone who's done pivot tables in Excel probably know that it can be a bit of a pain. And you also, a pivot table in Excel isn't long form data like this is. So it's not useful for charting, for example, straight away. Okay, so we're going to chart this. Okay, so we could just leave it the same and we get the same chart. Okay, because by default the geom column will be adding together the 2 rows, the 2 total rows. So we might instead wish to color by gender so that we can see what it's doing. So there we go. Okay, now obviously this isn't particularly good for comparing the distribution because the females start where the males stop, right, which is a bit silly. So we may use the position equals dodge, for example, in order to put them side by side instead of stacked. And so you can see this interesting dynamic where there's clearly more males than females all the way through schooling until we hit year 12 where things get close to balanced, and then year 13 when there's fewer males. So clearly males are leaving school earlier than females. So while there's, in both cases, there's this drop off as some students decide to leave school early, or earlier than the norm, I guess, males do so more than females. Okay. Right, so in the last chart, we produced a graph that looks like this. Let's see if I got the same one. That looks the same to me. Okay, notice I've done it a little bit, I've coded it up a little bit less, used fewer lines, but it's exactly the same code, right? I've just added labels and stuff there. So it's an interesting graph that shows that behaviour of males tending to leave school early, and we might want to then see if there's patterns in other variables in the data, such as ethnicity, or perhaps by region. There's lots of things we could potentially do here. And so we might want to assess this by different ethnic groups, for example. And that's what this next code block is doing. So you'll see there's actually two code chunks here. All right, there's this first one, which is taking our clean data set, filtering it so that we just get the European ethnic group, and then doing the same thing we did earlier, grouping by level and gender and summarizing the total number of students and then charting it. So this will be the same chart, but just for European students. So perhaps we should add a title here so that we see what happens. All right, so we'll do this. And so that's what the chart looks like for European students, where you see this big drop-off in males, just like we saw before. And that's not surprising because European students are the ethnic group that make up, that contribute the most to the total number of students, right? So you'd expect that you might see the same pattern in the biggest group. But what about Asian students? So here, same code again. We're filtering out Asian students first and then doing the same chart. So again, I should add a title here so that we can distinguish them. Okay. So that's what the chart for Asian students looks like. And you can see that it's quite different. You still see the same behavior, so more males than females, although it's not quite as clear cut in some areas, but again it reverses in year 13. Okay. So if I run it all, I'll have them both side by side, and then I can flick between them. But you notice that the general shape of the Asian one is quite different in that it has this dropping off behavior. And I believe that's a demographics thing. So the general population of the Asian ethnic group in New Zealand is increasing. And of course, as that happens, they have kids, and their kids go to school, right? And so that's why we're getting this increase here. So over time, that will probably stabilize into a similar sort of shape. Okay. Right, and you could do it for the Māori and Pacific as well, right? And also the other and international fee paying and whatnot. But it gets quite awkward because we have to do multiple charts. Okay, and then we'd have to combine them somehow on the page, and you know what a hassle that would be. So ggplot can do this grouping for us if we just add an additional grouping command, which is called faceting. So this is known as a small multiple plot. So what we do is we start by just grouping at yet another level, right? So we're going to compute the ethnicity by year and gender. So if we have a look at that. So we have the ethnic group, and for each ethnic group we have the year level and the total number of students of each gender. Okay, so here are our Asian students through to year 15, and then we have our European students through to year 15, and so on. And then there'll be the international fee paying and Māori students and so on and so forth, right? And then when we do the chart, we do it the same way. So we use a column chart in exactly the same way as we did before, but we add this extra line that says we wish to facet our chart by the ethnic group variable. So the vars function here is sort of somewhat similar to the AES function in that you specify the variables that come from your data frame. So columns in your data frame that are defining which plot each observation goes on. So when I run this, I will, instead of getting a single plot, I will get a grid of 6 plots. Okay, so here's our European one that we had before, and there's the Asian one that we had before, and now we get all of the others. So you can see, as you might guess, that international fee-paying students tend to be at the higher levels, right? At higher college levels. And obviously there's quite some difference in the total number of students, but you can see here that the Māori pattern follows pretty much the same as the European pattern. Perhaps there's slightly more drop off, but it's kind of the same with Pacific, similar pattern. Asians are a little bit different, and so is other. Okay. Now notice on this plot that that all of the scales are the same. So the y-axis and the x-axis are all the same. So that's a choice that you can make. You don't have to have them all the same. And in this case, it's possibly not super useful that they're all the same, because it's hard to see the trends in the charts that have fewer students in them. And perhaps it's not the total number of students that's of interest. It's the distribution of students that might be of interest. Okay, so we can do that by messing about with the facet wrap command. So let me take that code that's doing the plot. All right, so here's our plot again. And now we're going to look up the help for facet wrap, and we can see that there's this scales parameter, scales equals fixed. And when we go and see the help for that, should scales be fixed, the default, or free, or free in one dimension, free x or free y. So for example, here we might want the scales to be free in the y direction. I don't think we need to worry about them being free in the x direction. That might mess things up because the international fee paying doesn't look as though there's anyone in year 14 or 15. And you know, would use up extra space having the additional scale. So let's run free y instead. So you can see now that it's redone the plot and added a scale to each of them, which is allowed to be different. And so now you can quite clearly see the very different distribution of international fee-paying students. And you can see, you can more easily see the differences between the Māori, European and Pacific. So you can see that the Māori students tend to leave school earlier. Pacific tend to follow a little bit more a similar distribution to European and Asian for the later students. Asian don't drop off as quite as much as others. Okay. So instead of colouring by gender, produce separate plots for both gender and ethnicity. Okay, so we've got a new tool essentially for adding a new variable, right? So previously we've been using colour, and we've also looked at things like shape and size if you're doing, you know, a scatter chart. But this is another option, is producing a separate plot for subsets of the data. So we may do that instead of colouring for male and female. We could in fact just do a female Asian, female European, male Asian, male European. Right, so to do that, what we're going to do is we're going to take our same plot, and instead of colouring now, well, I could still colour, I suppose, but I'm just going to add gender to the variables used for faceting. And so now I will get 12 plots. Okay, so I've got a plot for Asian female, plot for Asian male, plot for European female, European male, and so on. Okay, now the color is not really needed here, so I could drop that if I wish, or I could just drop the legend. It's possibly still useful, just as a marker of knowing immediately which chart refers to which. Now the order here denotes which ones are used first and which ones are used second. So if I swap them around, all of the, so I'll do all the female ones first and then all the males, because the gender variable is the first one to split things up. You can change the number of rows and the number of columns. So for example, in this case, because I've got 6, I might want the number of columns to be 6. Right, so that I just get the females on the top and the males on the bottom. Okay, that may be what I want. I could turn the guide off. And so that's done with the guides function. So fill equals none. We'll turn that one off. And so there we go. That's one option for that chart. But there are many others, right? So this sort of allows you to compare across the rows reasonably well to see if there's sort of different trends, but it's harder to compare within each panel. So harder to compare female Asian with male Asian, for example, whereas that was much easier on this one because the bars were right next to each other. So it pays, of course, to think about what comparison you want to make. Now you could swap the role of these two if you did want to do it the other way around, right? So you could, let's do another one. So if we swap the order of gender and ethnic group, and then change it from 6 rows to 6 columns to 6 rows. Then we've got this one here where we've got the females on the left and males on the right. Now obviously this is a bit silly because everything is taken up by the space of the headings. Okay, so that's not a particularly useful chart. Not strongly useful unless we change the dimensions of the chart. Okay, which we could do. So if you want to change the dimensions of the chart, you can use fig.width and fig.height in the code chunk. So if you make the fig.width say 7, I think by default it's in some weird units which are called inches. I don't know if you've heard of those. So 7 and 12 inches. But basically, if you make the width less than the height, it will flip things around. So there it is there. You see it's longer than we had before. Okay, so that's how you can change the dimensions of the chart. The other way you can do it is because we've got 2 variables and essentially we're setting up a grid, is we could actually take advantage of the grid-like nature and use facet grid instead of facet wrap. And so that's what the last one is doing. Okay, so we could take the same code and use facet grid instead. So facet grid is used when you have 2 variables and you assign one to be the rows. So we could make perhaps gender the row and ethnic group the columns. And then we don't have to specify the number of rows or columns because it can figure things out itself. And let's turn off the scaling. Okay. And then what this does is it puts the variable that we're using for the rows, it labels them on the right. So the labels here are not taking up as much room as they did before. Okay, now the disadvantage of the grid is that you can only change the y-axis for the 2 rows and the x-axis for each column. You can't change the y-axis in the middle here, so we can't vary the y-axis across the panels going from left to right because the y-axis is only defined on the left. It's not defined in the middle like it was here. So it generally works best when all of your panels are on similar scales. So in this case, what we could do is we could look at the proportion of European students, European female students in each year level, so that the proportions were the same. And that takes care of, so the total sum would be 1 across each panel, and so they would have a similar y-axis scale. Okay, so you could do that like this. I'll show you. So we can't change the y-axis scale on a grid except for each column. There's a single scale per row. So you can specify scales equals free x, for example, free y, but all that will do is very slightly alter the scales of each row, right? So only very slightly here because the scales have been defined by the height of the European. And because there's slightly fewer females than males, that's why the scale here is slightly different to the males, right? But it doesn't solve the problem of different scales across the different columns. So what we could do though is we could take our ethnicity by year and gender, and we could group them just by the ethnic group. So you'll notice at the moment that it's grouped by ethnic group and level. So what I want is this proportion to be actually grouped by ethnic group and gender, I think. So I want the proportion in each year level. So I'm going to regroup it. So I'm going to group by ethnic group and gender. Okay, so now notice I've changed my grouping, and then I'm going to compute the proportion is going to be the total over the sum of the total. Right, so you can see here that what I've done is within the Asian female group, I've computed the proportion in each level. So I did that with a mutate within the group, so the sum here, sum of total, is being done within each group. So this is going to be the sum of Asian females or the sum of Asian males, for example. And so that's what the proportion's doing, and then I'm going to plot that. So let's pipe it into ggplot. And then the y-axis is going to be the proportion this time. And now everything is on somewhat similar scales. Okay, so the ranges go up to 0.3 because that's what the highest proportion in the international fee paying, but you can see I can more easily compare them because they are on similar scales. Okay, so it's just something to think about when you're using a grid. And so this is a very useful way of breaking down trends by subgroups. Because often what you may find is that what happens in terms of a general trend may differ once you look at subgroups. And so being able to easily divide the full data set up into subgroups and look at trends within subgroups is an important and useful way of gaining more insight into your data. So I'll just check that knits. So if we scroll down to that figure, you can see that we've got the big long one. It kind of looks a bit silly, but here's that one there. Okay. Right.